Hi, hello friends. Welcome to the today's session. Welcome to Unacademy. Welcome to Srinivasarao Sir classes. So today we are going to discuss some of the very important numericals on fixed length subnet masking. So last session we discussed that what is a fixed length subnet masking. Now we are going to discuss what are the different varieties of numericals are going to be asked in the examination. Before entering into the session, let us all say our anthem that Crack GATE and, crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures. My dear friends, Unacademy has provided a wonderful digital platform which are done by dedicated faculty members to serve the dedicated students. You can use this opportunity to clear all your dreams. Your dream is our dream, and our dream is an academy's dream. So, my dear friends, about myself, Srinivasarao IS, having more than 15 years of experience in the GATE with the various subjects, I also had industry experience and the backend side, that is the database and the system side, with the relevant good certifications. Throughout my journey of GATE, I taught in many premium academies with a high success rate, and many of my students got completed their post graduation from IITs and NIITs, central universities, and they settled their life and higher positions. So you also can achieve such just by taking a subscription in an academy. So Unacademy is providing two varieties of subscription. One is a plus course, the other one iconic batch. So plus course, once you become a member of Unacademy, then it is going to offer you live sessions like quizzes, mock sessions and mock tests. So all are beneficial to clear your competitive examination. So the second kind of subscription is iconic, which is inbuilt consist of plus course. In addition to that, it's a personal coach program. So you're going to get complete guidance till your subscription ends. And there are three varieties of subscriptions we are having primarily 12 months, 18 months, and 24 months. The current fourth year student and third and second year students can opt for 24-month subscription. By using my referral code, you are going to get a maximized discount. So use my referral code to get the maximized discount. So after discount, you're going to get a prices as like this. My referral code is eligible for any kind of a course which is there in an academy, not only for GATE and ESE. So according to iconic subscription, there are two varieties of subscription, 12 months and 24 months. My referral code is also applicable to this. I use my referral code to get the maximum discount and get the guidance from me. So after using my referral code, you're going to get a prices finally like this. So use my referral code and share with all your friends this knowledge. Then you see that you are also going to be benefited. So let's crack GATE CSC is our YouTube channel. Subscribe our YouTube channel. Use my referral code to get the maximum benefits as well as guidance and subscription into an academy. Hit the bell icon for latest notifications and updates. Dear friends, let us start the questionnaire on subnetting, that is FLSM. In the next session, we will discuss about VLSM. So today we are going to wind up the FLSM by solving the problems. So what is the first problem? In the IPv4 addressing format, the number of networks allowed under Class C network. So again, please observe carefully. Whenever I am talking about IP version 4 is nothing but 4 octal or 4 bytes concept. 4 octets or 4 bytes concept. So in that, so find the number of networks allowed under Class C address. So we know according to Class A, so 1 bit is reserved According to class B, 2 bits are reserved. According to class C, 3 bits are reserved. Therefore, my dear friends, so how many networks he is asking? He is asking about two-way hierarchy. So according to class A, we are having a N and triple H format. According to class B, we have double N and double H format. According to class C, we have triple N and H format. Therefore, you are being dedicated 2 power 24. But how many reserved bits? 3 reserved bits are there. And you got 2 power 21 networks. Let us crack the next question. Consider class C with 3-bit supernetting and identify the appropriate mask. So my dear friends, so when you talk about the supernetting concept, 3-bit supernetting, when you do, what is the appropriate mask? So it is nothing but, let us say, 255 and 255 and 255.0 is your default subnet mask. In the 3-bit supernetting you are doing. So mask them. You are going to get what is a new mask after borrowing. Your mask is 255 dot and 255 dot and 5 ones 248.0. So let us crack one more question. A subnetted class B network has the following broadcast address. Now he is asking you to find a subnet mask. This is a very interesting question this is. So subnet broadcast address is given of a class B. What is a class B? Double N, double H. And what is its default mask? 255, 255 and 0. Right? And now it is mentioned the broadcast address. What is the broadcast address? The HID parts are ones. That is the broadcast address. So let us see that 144.16 point. They are your net IDs. And 95 is your HID. 255 is HID. So let us write 144.16 point. What is a 95 binary? 95 binary is 128 is off, 64 is on, 32 is off, 16 is on, it's 80, 80 is on, 88. So 4217, it is 95. And 255 is 1, 2, 3, 4, 5, 6, 7, 8. All 8 ones 255. Now you see, when you get the broadcast address, you are going to see the consecutive ones. So when you see the consecutive ones, observe carefully. When you see the consecutive ones, 1, 2, 3, 4, 5, and this 8, this is completely your HID part only. What about these 3? You observe carefully. These 3 are nothing but your subnetted positions. So according to that, we want to identify which of the mask is suitable to generate 95.255. So 224, 3-bit subnetting means 224 is observed. 3-bit subnetting means 224. And 4-bit subnetting means 240. Even you say 240, I may leave up to here. And the rest of the 4 ones are there. Yes, it is also eligible. And 248 means a 5 ones best subnetting. Even I do 5-bit subnetting, then rest of the 3 ones are consecutive ones. And so therefore, your answer is ABC. I will give a shortcut to this. Observe. I am checking option A. What is your option A? It is 255.255.224.0, right? So what is a 224? This is N, this is N, this is H, this is H. What is 224? Triple N, 5 zeros. And this is 8 zeros. Now you tell me, your total octet size of the third octet total value is 256 minus 224, because it is being set to 224. The different varieties of subnets you will get from this. Otherwise, this octet, the size of your network is 2 power 5, 32 HIDs. So that is also correct one. 32 HIDs, 32 plus 32, 64, 64 plus 32, 96. What is 65 broadcast? It is 95. That's it. You got your answer. So option A is also correct. What is option B? It is 255.240.0. This is your network according to class B. This is your H. So 240 is nothing but 4 ones, 4 zeros. This is 8 zeros only. So your third octet has got 4-bit combination HIDs. So 2 power 4 according to this is nothing but 16 HIDs. Therefore you are going to get 16 block sizes. First is 0, then 16, then 32, then 48, then 64, then 80, then 96. Like that you will get. What is 80 broadcast? 80 broadcast is before 96 only, 95. Please understand. 80th subnet broadcast is 95. Like this here also. 64th subnet broadcast is 95. And if I check option C, it is given 248. This is one of your previous gate question. So that is a 255.248.0. So this is a N, this is a N, this is a H, and this is a H. So 248 means 5 ones, 000. And now, what is the value? Your host size in that particular third octet is 2 power 3, that is equal to 8 HIDs. Therefore, every subnet is going to have 88 subnet IDs on 88 HIDs only. So 0, 8, 16, 24. This is how you are going to get subnet IDs. I am writing subnet IDs. And 32, 8 difference you will get. 40, 48, and 56, 64, and 8, 72, and 80, then 88, then 96. What is 88 broadcast? 88th subnet broadcast is 95. That's it. This is one of the trick I have used to see that. What is your answer? What is your answer? All ABCs are eligible to provide this broadcast address. Otherwise, you follow the model 1, how I said. Let us crack next question. So a subnet has been assigned a subnet mask like this. What is the maximum number of hosts available? He is asking about HIDs. So HID is nothing but number of zeros are there in your mask. Because here class is not specified. So you need to set yourself that how many zeros are there in your subnet mask. These are all ones. And this is also all ones. And this is also all ones. This is a double one and the 6 zeros. That's it. You got your answer. So your number of HIDs are 2 raised to 6 minus 2. That is 62. This time He specified class B. It's a very important. Earlier there was no class. Here he specified class. Class B means double N double H. And your mask is given like this. 255, 255, 248.0. How many zeros are there? Don't say that there are 8 zeros. Or don't say that there is a 1 zero. You write your HID part in binary. 248 means 5 ones, 000. Here decimal 0 means 8 binary zeros. So how many number of HIDs? It is a 2 power 11 minus 2, which is 2046 HIDs. Against class B network only. He wants to form 64 departments. 64 departments means dash bits subnetting required. Dash bits subnetting required. So the answer is log base 2 of 64, which is nothing but 6-bit subnetting. So when you know 6-bit subnetting, he said that class B, according to class B, it is a double N and double H. So 6-bit subnetting is happened. Therefore, your mask is 255255, 6-bit manipulation. And here, no manipulation in the last octet. So what is the meaning of this? 255255, 6 ones means 252. So this is your answer. So you may get a doubt that how to do this. How to identify 6 ones means 242. How to identify 5 ones means 248. I already gave you while I was teaching the theory. When I say 1 and 7 zeros, its decimal value is 128. Double 1 and 6 0, its decimal value is 192. Triple 1 and 5 zeros, it is 224. 4 ones, 4 0, it is 240. 5 ones, 000, it is 248. 6 ones, 00, it is 252. And 7 ones, 10, it is 254. All 8 ones, it is 255. Please remember this while you are going to examination. Our next question is the class B. Again he is talking about class B, NNHH. So what is the default mask of class B? 255, 255, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 2, 3, 4. He is splitting 6-bit subnet number. Subnetting is nothing but masking onto your HID bits. So 6-bit subnetting number. They are becoming ones. So when they become ones, 6 ones are there. What is the meaning of 6 ones? Please understand. 6 ones means 252. Please drop there. Exactly that octet you need to write. So 255, 255, 6 ones means 252.0. This is your answer. Now tell me, 6-bit subnetting number means how many subnets? Dash subnets. How many bits are subnetted? 6 bits are subnetted. So you will get 64 subnets. Dash HIDs. How many zeros are there? How many zeros? Here 8 zeros. Here 2 zeros. It is a 2 power 10 minus 2 is your answer. So your answer is 64 subnets and 1022 HIDs. Because in HIDs we always see that starting number and ending number must not be used. Let us solve the next question. This is a very important and very good question. Now slowly I am increasing the complexity. So there are two computers A and B have IP address. This is AIP 10.1 105.1.113 and your B is 10.105.1.91. Both are using same mask. Mask is same. A mask is same as well as B mask is same. So which of the following masks should not be used by A and B? Therefore, they are belongs to same network. So which of the values of n given below should not be used so that they are going to belongs to same network? So let us write what is the class. This is very important. The class is A because your first octet is a given 10. Here also first octet value is given as a 10. Both A and B nodes are using class A. Okay. So according to class A, please observe carefully. It is n dot h dot h dot h. Right. Now which mask I should not be used between A and B so that they are going to say that they are both belongs to same network. If I use option A, what will happen? Otherwise, I can say like this. If I take option A, so option A mask is given that 255, 255, 2550. This is your option A. And what is the AIP? 10, 105, 113. This is your AIP. What is the subnet ID? Find out subnet ID. Subnet ID means, so whenever you see that 255 is here, you will get the same number as a subnet ID. Whenever you see 255, you will get the same number as a subnet ID. When I see this 1, there is a 255, you will get 1. So when you get 0 in the subnet mask, your subnet ID is 0. So this is your subnet ID. Okay. Otherwise, you can do ending. Ending also you can do. What is subnet broadcast address? The subnet broadcast address is, you will get the same octets because your mask is given 255. I cannot do any kind of manipulation. Therefore, you will get the same number. So you're going to get a different broadcast value here. Okay. Now let us see. The same I'm going to take for this is the A's IP. Now let me take B's IP. So what is a B IP? 10.105.1.91. This is your B IP. So what is a subnet ID? You will get the same 10.105.1.0. So your subnet IDs are matched. So I can say that with option A and B are same network because both subnet IDs are matched. So you cannot choose option A because he is asking that which mask is going to separate them. That is a very, very important. So second option 255, 255, 255, 128. Option B. Please observe carefully. Okay. So what is a AIP? Now I will do subnet ID in reverse. Please observe. AIP is 10.105.1.113. Okay. Now let us find the subnet ID. As it is a class A, it is a network, it is a host, it is a host, it is a host. I am doing a different way to find out subnet ID. I already taught you in the theory lectures. So network number we are not going to mask. And if you write 105 in binary, and how many bits are subnetted here? 8 bits are subnetted, 8 bits are subnetted, 1 bit is a subnet. Therefore, you will get the same number, right? In 128, how many bits are subnetted? 1 and 7 zeros. That means 1 bit is subnetted. So write your 113 IP in binary. What is 113 IP binary? It is 128 is of 64, 32, 96 and 16, 96 plus 16, 112, 8421. This is your 113 binary. As this bit is a subnetted, leave it. Remaining you make them to zeros. 1, 2, 3, 4, 5, 6, 7. What is your value? 0. And the same I am going to check with BIP also. What is BIP? Otherwise, I will find broadcast. Let us see. I will find broadcast also. What is your broadcast? You drop 0 as it is. You find all ones of your HID. This is your HID position after doing 1 bit subnetting in the 4th octet. This is your 4th octet. This is your IP 4th octet. So what is the meaning of this? Your subnet broadcast address is SBA 10.105.1.127. Now tell me, your 113 is in here only, as well as BIP. What is a BIP? 10.105.1.191. This is also available in this. Is this available in this? Because your broadcast is a 127 and BIP is a 191. 191 or 91 it is. It's a 91. So BIP is 91. So therefore, your 91 is available in this, as well as 113 is also available in this. Therefore, you cannot use option B because both of them are belongs to same subnetwork only. Even you do ANDing operation, you will get 0 once again. If I take option C and option D, let me do directly option D now. What is your option D? 255, 255, 255, 254. There are many ways to prove this. I will also give you another shortcut. Please learn. Any model will be utilized, or some models may be used, very much used in the GATE examination easily. So your AIP 10.105 1.113. So let us find the subnet ID and let us find the subnet broadcast address. So you will get 10 here, 104 here, 1 here. Now NNNH. So write 113 binary and 224 binary. 224 means 111 zeros. 113 binary already we wrote. What is that? 0 111 0001. Okay. How many bits are subnetted? These 3 bits are subnetted. This is your HID path. So take a border. Please hold on. I will give you a shortcut trick. Please hold on. Now make HID bits to zeros and ones. This is as it is. You drop 1, 2, 3, 4, 5. So you got what is the value? 96. What is the broadcast? Drop as it is. Make them to ones. What is the value? So 7 ones. It is 127. Now tell me, your AIP 113 is available in this, and BIP, what is your BIP? So 10.105.1.91, it is also available in. Therefore, you see that 91 is available as well as 113 is also available. So what is the shortcut? The shortcut is, if I am saying 192, I am checking with option C. Right? So N, N, N and H. So this is masked 1160. What is subnetwork size? Your subnetwork size is 2 power 6, 64 HIDs. So using this you can find the subnet IDs. This is another model. First subnet ID is 0. Second subnet ID is a 64. Next subnet ID is 64 plus 64, 128. And the next subnet ID is 128 plus 64, 192. That's it. So now see, your 91 is belongs to BIP 10.105.1.113 is available in this, and AIP and AIP 10.105.1.113. 113 is also available in this. Both are same. So if we take 255.255.255.224, yeah, option D. Option D, 224 means, so 11150, right? Now tell me, size of network. It is a 2 power 5, which is nothing but 32 HID. So your subnets are 0, 32, 64, 96, 128. Therefore, one of your IP is what? 91, and other IP is what? 113. So 91 belongs to 64th subnet, 113 belongs to 96 subnet. Therefore, these two are saying that they are varied. So option D is a correct for us. Now, let us take one more question. So broadcast address is given as like this. So similar question we already did. You also can try it. So what is the suitable mask? Let us take. So first 3 octets are 355. That means 255, 255, 255. This is going to be the vary. So our main concentration is 4th octet only. Please observe. So if I am taking option A, 4th octet I am talking 252, right? So 1, 2, 3, 4, 5, 6, 00. So your number of HIDs are 2 power 2 minus 2. That means you are going to get 4 sized, 4 based subnetworks. First subnetwork is 0, then second subnetwork is 4, then third subnet is 8, and so on. Otherwise, you can also do a different style. What is a different style? Write your 31 into the binary, last 5 ones into the binary, and 252 means 6 ones. So you see that the last 5 bits are going to be 1s or no. So according to that, 255, 255, 255, 252, 1, 2, 3, 4, 5, 6, 0, 0. This is your HID position, right? So there your HID position supposed to be, last octet supposed to be 2 ones. That's the meaning of broadcasting. So your IP is given as 289.69.31. 31. Now write 31 into the binary. This is your given IP. So 31 binary is 0, 0, 0, 1, 2, 3, 4, 5. This is 31 binary. Now listen. The last 2 bits are converted to ones. Yes, it is eligible. So you take another mask. What is another mask? 248. So leave it like that. 248 if I am writing. It is eligible or not? I am checking. It is 255, 255 and 255, 248. What is 248? 1, 2, 3, 4, 5, 1, 2, 3. So last 3 bits are ones or not? Yes. Perfect. And if you look at option C, what is your option C? It is given 240. 255.255.255.240. What is 240? 4 ones, 4 zeros. Okay, that means the last 4 bits are supposed to be ones in your 31. Yes, perfectly it is matched. So according to this, we understand that all of the above. Now let us see one of the complex question. So consider the missions MNP with address this and this and this. Mask is the same for everyone. They are using the same mask. We want to see that how many are belongs to same network. Same network means they're supposed to have same subnet IDs, right? So first 3 octets are same. 1, 2, 3, 1, 2, 3, 1, 2, 3. Our concentration is only last octet only. So this last octet is a 2, this last octet is a 5, this last octet is a 6. Now what is your mask? Your mask is, we don't require this because it's completely filled. Now there is a scope on last octet only. We are also checking last octet, right? So 252 write in binary. Okay. Now see that number of HIDs. According to this, number of zeros are there. How many zeros are there? They're all ones only. 8 ones here, 8 ones here, 8 ones here. And here you are going to have 6 ones and double zero. So number of HIDs are nothing but 2 power 2 minus 2. So your block size of every subnet, block size is equal to 4. That means you are going to get 4 sized subnetworks, right? Let me write. First subnet is always 0. Second subnet is plus 4. Next subnet is 8 because plus 4. Next subnet is 12 and so on. Now tell me, what is your first subnet? 0. And subnet broadcast address of your first subnet before of your next subnet. What is your next subnet? 4. So 0 broadcast number is 3. And 4 broadcast number is 7. 8 broadcast number is 11. Now tell me, 2 is in between 0 and 3. 5 is in between, please observe, 5 is in between 4 and 8. And 6 is in between 4 and 8. So what do we understand? N and P R belongs to second subnet, that is a fourth. So for second subnet, the N and P and M belongs to first subnet because 2 belongs to 0 at the subnet only. So this is very simple to solve. This is a 2 marks question. What is our idea? Your N subnet ID 5 and P subnet ID 6, R belongs to this particular, but whereas M subnet ID belongs to this particular. So your answer is N and P or belongs to same subnet and M is separated from there. Why it is separated? Let me write. So M subnet ID is, take your IP 10, 100, 10, 5. So your subnet ID is 0. What is N subnet ID? N IP belongs to second subnet, that is 4. And P subnet ID belongs to this also 4, right? Because you are the one of the host. Your host is a 5 and 6 are belongs to this group only. 5 and 6 are belongs to this group. But your 2 is belongs to not in the second network. Your 2 is belongs to your first subnet. So let us answer next question. So this also can be simply answered. Please see that theory is different of your IP addressing and numerical solving is different. Different methods, all are based on binary manipulation only. If you know the binary manipulation well, then you can do that's the IP addressing on fingerprints. Now, there is a routing table is given. The routing table consists of destination and a mask and interface. This is your destination is using this mask via E0 interface. This is your destination and these are your destination. So on which interface the router forward the packet address to the destination? So a packet has destination address 128.75.43.16 and another one is 192.12.17.10. If you observe one important thing, 128 belongs to class B and 192 belongs to class C. So you please check second IP with the class C and you please check first IP with class B. So the class B answers may be E0, E1 and class C answer may be this E3. So there is a one important analogy we all know. In order to have the communication, class must be the same, network ID must be the same, and subnetwork ID must be same according to three-way hierarchy. Class must be same, net ID must be same, and subnet ID must be same. If you are using router, then I can able to have the cross communication also. Now let me check first IP with E0 and E1. So subnet IDs I am checking because 128.75.43, 128.75.43. Next 128.75.43. Our main intention is what? Which mask I supposed to use so that I am going to get subnet ID as a 0? Whether you use E0 mask or E1 mask. So destination address is 128.75.43.16. And what is E0 mask? This is your E0 mask. I am checking with E0 mask. So find the subnet ID because net ID is the same. So when your subnet mask has 255, you will get the subnet ID same number only. When you get 0 in your mask, your subnet ID becomes 0 and broadcast becomes 255. Please remember these tricks. When you get subnet mask 255, you will get subnet broadcast address and subnet ID same octets only. No doubt. So same octets only. When you get 0, subnet ID will become 0, subnet broadcast by become 255. So now you tell me, you got 0, right? So it is matched. Perfect. So it is trying to transmit via, please observe carefully, E0 if I write. Let me also cross check with E1. Don't leave it. You also cross check with E1. So your IP is 128.75.43.16. This is your destination IP. And E1 mask is 255.255.255.128. So you need to find a subnet ID. I already told you, when a mask has a 255, your subnet ID and your subnet broadcast address will be the same digits. Here also same. Here also same. And this is going to be the vary. So 128 means what? Write 128 in binary. 1 7 zeros. That means this bit is subnetted. And this is your HID position. And a 16 binary. 128, 64, 32, 16, 8, 4, 2, 1. Right? So you leave the gap of the first one because it is subnetted and write, drop it and remaining you make them to zeros. So you also got 0 for this, right? That means this is also 0, this is also 0, therefore you got this also same. So which one you are going to choose, E0 or E1? We are in ambiguity because subnet IDs are matched for E0 as well as E1. Subnet IDs are matched for E0 and E1. Therefore, we need to choose always highest masked mask, highest subnetted mask. If you take E0, number of ones are 24 only. If you take E1, the number of ones are 25. That's why we will choose E1. So E1 is our answer. So the same we want to do for class C also. That is second IP 192.12.17.10. So we know that this is a class C. So use mask of E3 because it is a class C. But you observe, as I said that it is a class C, N, N, H, H. I told you three important things for communication. One is class must be same, NID must be same, subnet ID must be same. But according to this, what is the answer he is checking? 192.12.17. Impossible. Why it is impossible? Because you will get the same 192.12.17 and you are going to get some number here. And this is not matched with, it is not matched with E3 number, E3 subnet ID. Because E3 subnet ID is 192.12.17. But here I got differently. What is that? 192.12.17. 192.12.17. Now you need to check the fourth octet, whether it is equal or not. So what is the mask is given to you? The mask is given to you 255, 255, 255, 255. So whenever subnet mask is given as a 255, then what are you going to get? You will get 192, you will get 12, you will get 7, you will get 10. Now question mark is removed. You will get 10. This 10 is not equal to E3 subnet ID. It is given 5. Therefore, your packet will be transmitted whenever subnet ID is not matched. Your packet will be transmitted via default route. That's why every router is going to provide a default route. This is your default route. Therefore, your second packet is going to be transmitted via default route. Therefore, this packet forwards via default route, right? So default route, what is the number? E2. So our answer is one is E1, one is E2. Any doubt, you please tell me, my dear friends. We'll discuss. Let us see the next question. This is also a previous gate question, similar to the previous only. So you also do the same. So 117 belongs to E0, E1, E2, E3 subnet IDs. So take every mask and check with your destination. Okay. So it is a class B, right? 144 means class B. Class B means double N, double H. So first two bytes are same. So we cannot skip any answer. And next two we are going to solve. What is that? 68117. So what are the respective mask positions? 0, 0. Third octet and fourth octet only I am writing because first two octets are same. 0, 0. This is your mask. So whenever your mask is 0, you will get 0 as your subnet ID. So you got 0.0 with the first two octets. Yes, it's matched. So your answer is E0 is correct. But don't leave. Let us check E2 also. E2 mask is 224.0. This is option A. Option B I am doing 224.0. And your IP is 68.117. So some manipulation you have to do here. So here 224 means 11150. This is 8 zeros. Now see, these 3 bits are subnetted, and this is your HID part. So you also write 117 in binary and 68 in binary. Otherwise, as this is 0, your subnet ID in the octet will be the 0, no doubt. So our concentration on to 68 only. So write 68 binary 0 1 0 0 64 32 16 8 4 2 1. How many bits are subnetted in that octet? 5 bits. So leave the 5 bits and convert them. Drop 0 1 0, convert them to zeros. So what is its value? This octet value, we got 64. So you got 64.0. This is also correct. Don't leave, you need to check with E2 also. E2 is a 22255.0. So we are going to consider this and this only, not the first 2 octets, as they belongs to NID. So 255 means all ones, and 0 means 1 2 3 4 5 6 7 8. So whenever you got 255 there, if I write your IP over there, what is your IP? Last 2 bytes I am writing 68.117. So you will get, what is your subnet ID? Your subnet ID is, you will get the same number. Whenever your mask is given with 255, your subnet ID and subnet broadcast will be the same, 68. So your mask is given as a 0, then you will get as a 0. Is it equal to that particular subnet ID? Yes, it's also equal, 68.0. So hence, we are going to choose what? Highest number of ones or highest length of the mask we are going to take whenever you are going to select that multiple options are selected. So whenever multiple subnet IDs are selected, you please choose the highest length of mask. So here highest length of mask is actually E3, but we want to know that whether E3 is satisfied or not. So you please also check whether E3 is satisfied or not. Then you go for answer either E3 or E2. Or you can come in reverse approach. What is reverse approach? You start your problem with highest length of masking towards to lowest length of masking. If it satisfies, that is only your answer. This is how you can also quickly do your problem. Do start with the highest length of mask to lowest length of mask. So your answer is E2. Anyhow, this is not going to be satisfied. Now let us take the last question. So host X has IP this and connected. X is connected via 2 routers to Y, and they're all using same mask 255.255.255.224. So how many distinct subnets are there, right? This is a class C because 192. Therefore, it is a class C. Class C means triple NH. So write 224 in binary. So 3 ones are there in that. Therefore, number of subnets are 2 power 3, that is equal to 8. 2 power 3, that is equal to 8 subnets. And the last question is, this is one of your previous GATE question. Match the following. So I am taking this IP, destination IP. I am going to check with E0 mask and see that you are going to get network number E0 or not. Otherwise, You check with E1 interface and see that are you getting E1 or not. First I will show you one and rest you continue. So I'm going to check what 128, 96, 171, 92. With what is the mask? E0 I am going to check because he is asking you to check with 1. 1 is nothing but E0. What is E0 mask? 255254.0. Okay. 128 means it is a class B. So class B means it is a NID, NID, HID, HID. This is our task because your subnet ID will be the same. Because as there is a 255, your subnet ID will be the same. Otherwise, NID we are not going to disturb, you drop it as usually. So when you get a 0 here, your subnet ID is 0, no doubt. And this one is our concentration. Write 254 in binary. 7110. Write your given IP in binary. So this is your subnet position and the last bit is only HID for you. Write 171 binary. What is 171 binary? 128, 32, 60 हो गया. And 11 we want. 16, 8, 4, 2, 1. Okay. So this is a completely subnetted position. Now the last bit is your HID. So leave that gap, convert your HID to 0. So 101010 what is the value? It is 170. Have you got this answer or not? Is it matched or not? 128, 96, 170.0. Yes, it's perfectly matched. So your answer is either A or B. Now again we want to break this. How? B is nothing but I want to check with 3. That means B you check with 3 R2. What is your B? Your B is 128, 96, 167, 151. One 151 and use that 3. What is the 3? R2 mask use this time. What is your R2 mask? 255254.0. Now find the subnet ID. Is it equal or not? So you will get 128, 96 no doubt as it is NN and HH. So this will be the 0. Now our target is this octet only. So you know 254 binary is 1, 2, 3, 4, 5, 6, 7, 0 and 167 binary you write. What is your 167 binary? 128, 64, 32. So almost all 160 ho gaya. Now 7 we need. 16, 8, 4, 2, 1. So how many bits are subnetted? Again same story. 7 bits are subnetted and last bit is for HID. So leave those subnetted positions here. So your HID, what are we going to do? Drop it. Convert to 0. What is this value? 166. Is it matched or not? 1 to yes, it's a perfectly matched. So option A is correct and option B is wrong. That's it, my dear friends. So I want to give you a task to you. This is your task. Please solve this task on your own. If not, you can mail back to me. Otherwise, we can discuss in next some other session, tomorrow's session. And use my referral code to get the admission into Unacademy, because I can be your guide and I can give you guidance till your subscription ends and GATE examination ends. So today we have learned about few important questions on subnetting, fixed length subnet masking, because already we learned the theoretical approach of FLSM, class C, class B, class A. In the next session, we are going to discuss about VLSM, variable length subnet masking. Don't miss tomorrow's session, that is VLSM part 1, day after tomorrow VLSM part 2 and a questionnaire. Stay tuned to Unacademy, stay tuned to my classes. We will meet in next session. Thank you very much for your cooperation.